chapter 2.2 is organizing quantitative data. So when your data is actually has a numeric values, so either discrete or continuous numeric values, what kind of graph that we would use to summarize this data. To make a long story short, there are various different data, the graphs that you can use for the quantitative data. But here we will be briefly talking about the histogram and semi-leaf plot. Histogram, I am pretty sure that you've seen it before. It looks like a bar graph, except your x-axis actually has the numeric values. So your bars are actually touching, unlike bar chart that your bars are not really touching each other. So anyway, so those histogram and semi-leaf plot we will be talking about. To do so, we're going to look at this example, job satisfaction score for 20 fast food employees. So there are the 20 responses from the 59, 60, 4, 42 to 74. So those are the scores. So to use the stat crunch, I actually just go ahead and type it in. And sometimes, you can get a data set that is already available for the textbook, or you can actually, if you have a data set in Excel form, you can actually upload it as well. For this particular case, I was only 20 numbers, so I just decided to type it in. So here, I go StatCrunch there. So what I did is if you go StatCrunch over there, you can actually click the new data table. So if you click that, it will actually give you empty spreadsheet. Then you can start to just write satisfaction there. And then I just, wrote those numbers there. So that's my data set. Okay, now we're going to do the histogram. But before we do the histogram, I'm pretty, again, sure that you probably have drawn this chart, the frequency table before. So you think about the case and then count the frequency. So from class 30 to 39, how many your data set belongs here, and how many data set belongs 40 and 49, and then so on and so on. And relative frequency is just 1 over the total frequency, which is in here is 20. So 1 over 20 become 0.05. 2 over 20 is 0.1, and so on and so on. And I'm pretty sure previously you probably used this number, and then in x-axis you use this class, and then y-axis relative frequency, and use the histogram. So you can actually draw it by hand, but really nobody draw histograms by hand anyway. So we will be just drawing it in StatCrunch here. Go back to my StatCrunch. So here, graph, we're gonna play with these two, like histogram and semi-leaf plot. So first histogram, just click that. The only thing you need to do is satisfaction. Oh, and one more thing. You can either use frequency, which is actual count, or relative frequency, which is actually percentage. Tend to use the frequency, a relative frequency a little more. So I'm just gonna use that. And then compute. Then you're going to have this stem-and-leaf plot, histogram. So you have satisfaction scores there, and relative frequency there, percentages there. And as I hinted a little bit before, here for the histogram, those bars are hitting each other, right? Right next to each other. For the bar chart, it wasn't really hitting, right? It was kind of separated. But since it has a numeric meaning, your bars are touching there. You might wonder, can I actually change the width of the bar? And what if I want to do 30 to 35? I mean, for this particular example, this is probably just fine histogram, but you might want to change those width as well. Want to point that out. I'll go back to histogram and do the exactly same thing. And if you want to do that, change the width of the bins, bars, bins, go there and say try the 5, then compute. Then you're going to have the histogram that has width of the bar only goes to 5. So in that way, you can change it. You can change the color and all those kind of different things. But well, that's the histogram. Other thing, one more thing is a stem and leaf plot. So do the same thing. Not that one, not that one. I think that's the only thing that you need to do. Just go to satisfaction, and then it will give you this chart. The stem and leaf plot is nothing more than you're going to have a stem, the very first column. Okay, so 3, 4, 4, 5, 5. So when it has the 3 and 40, 4, 4, that means that if it's 30 and 44, the 40, the lower 40, upper 40, lower 50, upper 50, and so on. And then you are writing actual data on the right hand side. So for each of the data sets. So this means there is 36, 41, 42, 51, 51, 52, 53, 54. Those are actually your data set. So in a way, if you actually compare this thing to stem and leaf, the original histogram that you draw, it actually looks very similar. If you just turn your, I guess this one actually has the 5 for the width, so this one will be probably the one. So there's a 1 data point, 2 data point, 0 data point, and 1, 2, 3, 4, 5 data point, right? So if you turn around your head 90 degree on the left hand side and looking at the semi-leaf plot, it actually looks very, very similar to your histogram. But one of the benefit is it actually has actual data set in it, so you can kind of retract uh, what value it is. So anyway, so that's a stem and leaf plot. Okay, so if you look at the slide, it actually has a review of it. So there's a histogram of it depending on what the width is. And this particular graph is actually drawn using Minitab, which is very similar to StatCrunch. But it looks just a little bit different, colors and stuff. And if it's a semi-leaf plot, don't worry about the very first thing. It was just some kind of count thing. So for this version, your stem is actually the second column, and the leaf is the third column. So again, this one is made in Minitab, so it looks a little bit different. But if you just ignore the very first line, the first column, then it's actually exactly same as the semi-leaf plot drawn at StatCrunch. This is this optional thing that you can do in your textbook. Look at these examples. It just gives you a slightly different version of graphs. For example, page 92, there is the example about McDonald's and Burger King fat content. They draw a stem leaf plot, but since they want to compare those two, they put the stem in the middle and then leave one for Burger King, one for McDonald's, so they can actually back to back kind of compare it. So if you look at it, it will actually make sense. And then there's also some time series graph, which means x is the time. As time goes on, what's happening to your variable. Those are available there too. So it's just a purpose of showing you from different type of graph depending on your data set. Okay. Okay. So next thing, we're going to talk a little bit about the different type of distribution shape. So these are all, you can kind of guess the histogram, right? So this is a histogram of it. And then it looks like it's somewhat based on real data set. So if you look at this part of it, it is approximately symmetric, right? What symmetric means that on the right-hand side and left-hand side to the center has almost the same shape. So this one is an example of symmetric. On the other hand, some data sets will have skewed. So rather than symmetric, the same left and right hand side, it will have a long tail here, the smaller value, and then most of the data set will be belong the bigger number. And this one will be skewed in this way. There are a lot of data set on the left hand side and then has a long tail there. But both of them are skewed case. This particular one, the middle one, is called skewed left, and this one is called skewed right. Sometimes that left and skewed, the right is a little bit confusing. Other name is this one is skewed negative, and this one is skewed positive. Um, this works for me all the time, so I actually strongly recommend you to use it. When you take your left hand and just naturally do this, right? And then look at your graph, your screen, your left hand, that's skewed left. Instead, if you use the right hand, that's skewed right, right? So if it's a left, and if it's a right. Okay, so because it's really hard to do this way, right? So if it's a natural way, so if it's the right and if it's the left. So these three sets of the data set, the shape, the figure will tell us symmetric or skewed. And if it is skewed, one is skewed left and the other one is skewed right. Um, what kind of data set would look like that since we are here? The symmetric, a lot of natural measures probably will look like that. So, for example, say height of male college student or something like that will actually have everybody will be somewhere between 6 and 7, and then there are a couple of them short, a couple of them are really uh, tall and stuff like that. Skewed right is actually a common shape that then you actually can imagine. For example, income is a very good example of skewed right case. Most of them, most of American, I guess American income will make somewhere around 0 to 50,000 a year or something like that. And there are only a few Bill Gates and that Amazon guy and Tesla guy, and those people are maybe all over here, but there are only a few of them. So skewed right is that. Skewed left um, is a slightly less popular, less common shape, but you can imagine that. I guess for particular class, I uh, the instructor gave you really easy exam, which means most of you will get a really good score. But if you didn't study at all, you will still probably not going to have a good grade. So left skewed is probably the shape of those test scores. The next set of graph is talking about how many bumps the distribution has. This one, again, it's the real data, so it's not exactly same probability, but it's roughly for each bins, for each categories from the beginning to the end, it has roughly same probability. So when it has all the similar probability from the beginning to the end, we call it uniform distribution. So uniform means it has a same close, right? The same probability kind of idea. So we call that uniform distribution. Um, if there's only one mode, we call it unimodal. If it has a two bumps, we call it bimodal. If it has a multiple bumps, we call that multimodal. Okay, so how many modes you have, how many bumps you have, has a different name of the shape. These are just a couple of websites that if you actually have time and are curious about, check those websites out. Those are interesting, statistically very interesting sites, and some of them will actually use it at some point in the class. But those are just check it out, okay, on your own, and that should be fine. Okay.